Now, let us look at an example of how to construct a simple network diagram. This example will look at the calculation of critical path and the determining of the floats of each activity. We are presented with this information. We are quite familiar with this information because we looked at this in our previous lessons, especially in the construction of the Gantt chart. We need to sketch how the network diagram would look like before proceeding to draw the actual precedence diagram. So when you look at the table, activity A is a starting activity and it precedes activity B and C. So we would have that A preceding activity B and C. From the table, B and C also precedes D and E, and that is represented. And activity D and E precedes activity F. So our network diagram will look like this, and we can rely on this sketch to draw our precedence diagram using the notation early start, duration, early finish, and late start, float, and late finish. So let's proceed and draw the network diagram. So we have activity A, which precedes activity B and C, and activity B and C precedes D and E respectively. D and E acts as preceding activities to activity F. Now, let us indicate the duration of each activity within the duration column in the network diagram. So activity A has 2, B has 3, C has 2, D has 5, E has 3, and F has 2. At this stage, we would do the forward pass and later conduct the backward pass. In doing the forward pass, we are going to have our early start and early finish values for each activity. So for activity A, the early start is 0. To get the early finish of activity A, we add the early start to the duration, and that will give us 2. This 2, as the early finish, becomes the early start value for the succeeding activities. So activity B and C would have 2 as their early start activity. So let's look at activity B. So the early start is 2, and this early finish will be 2 plus 3, giving us 5. For activity C, 2 will be its early start plus 2, which is its duration, giving us 4. For activity D, the early start will be 5 plus 5 is duration, giving us 10. And for activity E, the early start will be 4 plus 3, which is its duration, giving us 7. Now, which of these early start values becomes the early finish? Which of these early finish values then becomes the early start value for activity F? Activity D and E are activities that have to be completed before activity F commences. Now, activity E completes in a duration of 7, whereas activity D completes with a duration of 10. So until all the activities are completed, activity F cannot start. So in this case, the finish of activity D 3 days after activity E will lead to the commencement of activity F. So 10 is the early start for activity F, plus its duration of 2, giving us the early finish of activity F. Now, at this point, the early finish becomes the late finish in starting the backward pass. So we have 12 as the late finish or latest finish for activity F. And in order to get the latest start, you subtract the duration from the latest finish value, giving us 10. Now this 10 will then move as the latest start value to D and E as their latest finish values. So we deal with D and E. Now, the latest start for activity D will be 5 minus 10, or 5 from 10, giving us 5 as its latest start. And for activity E, it is 3 minus 10. That is the duration out of its late finish value, giving us 7. And we proceed to activity C and D. So the late finish of activity B and C will be the latest start for D and E respectively. So for activity D, 5, which is the latest start value of D, becomes the latest finish of D. And 2 becomes the latest start of activity B, because 3, which is the duration, is taken out from the latest finish value of activity B. For activity C, 7 becomes its latest finish, and 5 becomes its latest start, because the duration has to be taken away from 7 in order to get 5. The smallest value is what we take between these two activities, B and C, to become the late finish of activity A. And 2 out of 2, that is the late finish of activity A minus the duration, which is 2, giving us 0 to complete the backward pass. Now, let's determine the critical path. We know that the critical path is the path with 0 floats. So let us find our floats from activity A. The float is the latest start minus the early start, or latest finish minus the early finish. So for activity A, 0 minus 0 gives us 0. Activity B and C would have 0, and activity D would also have 0. Activity F will also have 0. Activity C and E will have 3 apiece. Now, the critical path is a path with 0 floats, as indicated in red, and also the longest path through the network, not with the most number of activities. So the path with thick red arrows becomes our critical path. If any activity has a delay, it will lead to an extension of the completion date. In other words, all the activities on this path doesn't need any interference. We can interfere with activity C and E within 3 days so as not to cause any delay in the completion of the project. So the critical path here is activity A, B, D, and F.